Hello everyone, my name is S.N. Patil. In this video lecture, we will discuss the Newton-Raphson method. So first of all, here we consider approximate root of the equation f of x. Okay. Now, instead of x naught, we consider the x1 is correct root so that f of x1 is equal to 0. x1 is x naught plus h. Okay. Now we use the Taylor series expansion for f of x naught plus h. Is f of x naught plus h f dash x naught plus h square upon 2 factorial second order derivative at x naught plus h cube upon 3 factorial third order derivative at x naught plus so on is equal to 0. Okay. Now here the h is very small number. Okay. So that the square of h, cube of h, okay, is very, very small. So that we neglect the term of equation 1 from h square from third term. That is, we neglect h square, h cube. It becomes simply f of x naught plus h plus into f dash x naught. Now put this f of x naught in right hand side. Then the remaining term, see, when we put here, then h is equal to h of f dash x naught is equal to minus times f of x naught, and then f dash term is divided here. So h is equal to minus f upon f dash. F dash is derivative, but the value of the h, see, here we consider x1 is equal to x naught plus h. Then the value of h we can substitute. H is equal to x1 minus x naught. We substitute here. Okay. Then what we get? We get x1 minus x naught is equal to minus f at x naught divided by its derivative at x naught. Now put this x naught in a right hand side. So we get x1 is equal to x naught minus f at x naught divided by its derivative at x naught, and provided f dash must be non-zero. Now this is the first approximation. Okay. So first we consider x naught be the approximate. Okay. Now from that we get the first approximate root x1 is equal to x naught minus f upon f dash. Now successive approximation is given by x2, x3. Okay. Then the nth term will be x suffix n plus 1 is equal to x suffix n minus f at xn divided by f dash at xn. Okay. Here n is running from 0, 1, 2 and so on. Now this formula is called Newton-Raphson formula. Now let us take the example on Newton-Raphson formula. Find the real root of x cube minus 2x minus 5 by Newton-Raphson method, correct up to 3 decimal places. Okay. So let f of x is equal to x cube minus 2x minus 5. Say equation number 1. Okay. Now the requirement of the Newton-Raphson method is first approximate x naught root. Okay. Now here selection is which value we should select for the x naught. So for that, we use intermediate value theorem. We identify the interval in which the root is lies. Okay. So for that, we use trial method here. Put x is equal to 0 here. When we substitute x is equal to 0, then we get 0, 0, and here minus 5. Now put next value, put x is equal to 1. X is equal to 1. Here 1, here minus 2 into 1, minus 2, minus 5, minus 7, and 1. Okay, that is minus 6. Now same sign. Now next put x is equal to 2. X is equal to 2, that is 2 cube minus 2 into 2 minus 5. Okay, that is 8. 8. This is minus 4, minus 5, minus 9, plus 8. We get the minus 1. Again, we get the same sign. Now the next, put x is equal to 3. That is 3 raised to 3 minus 2 into 3 minus 5. Okay, that is 27 minus, here this is minus 6 minus 5 minus 11, and this 27. Okay, 27 minus 11, that is 16, plus 16. Now see here, we get the opposite side. Opposite side. Okay, it means root is lies between 2 and 3. Root lies between 2 and 3. Okay, now we choose the x naught here for first approximation. Here we can choose the x naught as a 2 point something, yeah, 3. Okay, but the value should be lies between 2 and 3. 2 and 3. Okay, so for first approximation, so instead of that first, okay, root lies between 2 and 3. So we choose x naught is equal to, let x naught is equal to 2, suppose. Okay, now here we write here generalized formula first, and then we put the x naught value. Okay, by Newton-Raphson method, by Newton-Raphson, generalized formula is x suffix n plus 1 is equal to x suffix n minus f of x suffix n divided by f dash suffix n. Okay, here x suffix n minus the value of f of x is x cube. X cube minus 2x minus 5 divided by its derivative. The derivative is 3x square minus the derivative of minus 2x is minus 2. Okay, and then suffix n, suffix n, suffix n. Okay, now the 3 times x square minus 2 is multiplied to this x. It is x suffix n into 3x square minus 2 minus, okay, minus here x raised to 3 minus 2x minus 5 and divide by 3x square minus 2. Okay, so here first we make it generalize, then we put the value of n is equal to 0, 1, 2, and so on. Okay, let us first simplify. X suffix n plus 1 is equal to is equal to, now here n, here n is equal to 3 times x square minus 2 and suffix n. Now here x suffix means x multiplied here 3x square, and here sorry, x multiplied 2x square, that is 3 times x cube, and this x cube 3 minus 1, that is 2 times x cube. Now minus x is multiplied to the minus 2, that is minus 2x, and this minus sign is multiplied to the 2x, minus plus 2x cancel. Okay, now minus sign is multiplied here. Now it become simply 5 plus 5 is remaining. Okay, and suffix n. We get here the formula 2 times x cube raised to 3 plus 5 divided by 3x square minus 2. So this is the general formula. Okay, otherwise instead of general you can put direct here n is equal to 0 and go step by step. This is also okay, no problem. Say equation number 2, put n is equal to 0, 1, 2 and so on. Okay, when we put n is equal to 0, that is the first approximation. Put n is equal to 0. Here 0, then we get first approximation, x1 is equal to 2 times x raised to 3, and the value is 0 plus 5 divided by 3x square suffix naught minus 2. Now we already choose the x naught is equal to x naught, we choose x naught is 2. So substitute here 2, x1 is equal to 2, here 2 cube plus 5 divided by 3, substitute the 2 here, minus 2 is equal to. Now here we get the, by calci we get this value is x1 is equal to 2.1. Now put n is equal to 1 in equation. Put n is equal to 1 in equation 2. We get x2 is equal to, n is equal to 1 here. x2 is equal to 2 times x cube suffix 1 plus 5 divided by 3x square suffix 1 minus 2. Now substitute the value of x1. Okay, that is 2 times 2.1 plus 5 divided by 3, 2.1 raised to 2 minus 2. Okay, just better. Now by calci 2 x raised to 3 plus 5 so here we get the value is x2 is equal to 2.0945. Okay, now the next iteration put n is equal to, put n is equal to 2. Okay, in equation number 2, here put n is equal to 2 here, then the formula become x suffix 3 is equal to 2 times x raised to 3 suffix 2 plus 5 divided by 3x square minus 2. 3x square minus 2. And the value of x2 we have just calculated. Substitute 2 times the value of x square is 2.0945. 2.0945 raised to 3 plus 5. Okay. 3 into 2.0945 raised to 3 minus 2. Okay. Now just better 3 times 2 point. Then we get x3 is equal to in same value 2 time just better. We get the same value. 2.0945. Okay, this is the x3. Okay, now we stop the iteration here. The question is find the real root correct up to 3 decimal places. That is 1, 2, 3, and the fourth place is greater than 5. So greater than 5 is equal to 5 or greater than 5. Then we add here the x3, the approximate root 2.095. Okay. Now next problem. Find the real root of x cube minus 5x plus 3 is equal to, is equal to 0 by Newton-Raphson method, correct up to 3 decimals. Okay. Let f of x is equal to, x cube minus 5x plus 3. Okay. Say equation number 1. Now here x naught is not given. So first we identify the interval. So put x is equal to 0 here. Put x is equal to 0. Now here 0, here 0. Then only 3 is remaining. Put x is equal to 1. Here 1. And this 3. 1 plus 3, 4. And here 1. 5 into 1. That is 5. And this minus sign. Minus 5 plus 4 minus 1. So these are the opposite sign. Opposite sign. Okay. That is root lies between 0 and 1. Okay. Here we assume the approximate value. So in first problem, we assume approximate value as a 2. Okay. So here we consider approximate value lies between 0 and 1. That is choose x naught is equal to x naught is equal to we instead of 0 we choose x naught is equal to 0.5. Okay. Now first here we identify the generalized formula of Newton-Raphson. By Newton-Raphson, x suffix n plus 1 is equal to x suffix n minus f divided by derivative f dash. Okay. Now x suffix n minus f is x cube minus 5x plus 3 divided by its derivative, that is 3x square minus 5. Okay, suffix n, suffix n, suffix n. Now simplify. We get here 3x suffix n, 3x square minus 5 minus x cube minus 5x plus 3, and denominator is 3x square minus 5. Suffix n, suffix n, suffix n. X suffix n plus 1 is equal to now here x is multiplied to this x, it become x cube, 3x cube and minus x cube, 3 minus 1, that is 2 times x cube. Now x is multiplied to the 5, minus 5x, and this minus sign is multiplied to the minus 5x, minus minus plus, plus 5x and minus 5x cancel. Okay, now minus sign is multiplied to the 3. So here minus 3 and divided by 3x square minus 5, and right here suffix n, and n is equal to 0, 1, 2, and so on. This is the generalized formula for finding the approximate root of the given equation. Okay, to put n is equal to 0 here, put n is equal to 0, then first approximate root x1 is equal to 2 x naught raised to 3 minus 3 divided by 3 x naught square minus 5 is equal to 2. Here the value of x naught we select 0.5 raised to 3 minus 3 divided by 3 times 0.5 raised to 2 minus 5. Okay, just wait. Minus 5, 0.5 cube. To 0.5 cube minus 3. Okay, divided by 3 into 0.5 bracket square minus 5. Okay, so we get here 0. X1 is equal to 0.64. 64705. Okay, now put n is equal to 1. N is equal to 1. Say equation number 2. In equation number 2, that is x2 is equal to 3x cube suffix 2. Sorry, we put n is equal to 1. So here 1 minus 3 divided by 3x square suffix 1 minus 5. Now substitute the value of x1. 3, 0.64705 raised to 3 minus 3 divided by 3 times 0.64705 raised to 2 minus 5. Okay, 0.64. Okay, so we get x2 is equal to 0.6567. Now next iteration, put n is equal to 2 in equation. Put n equal to 2 here, then 3 here, 2. That is x suffix 3. Okay. Now here 2 x cube suffix 2 minus 3 x suffix 2 minus 5. Okay, 2x cube. Now here put the value of x2. x2 is equal to 2 times the value of x2 is 0.65 0.65657 raised to 3 minus 3 divided by 3 0.65657 raised to 2 minus 5. Okay, through calculate the value 0.65657. So we get value x3 is equal to 0.6566. Okay. Now the question is find the up to correct 3 decimal places. That is 3 decimal places 1, 2 and this 3, and the fourth place is greater than 5, 0.65. Now add here 1. Okay, so this is the approximate root of the given equation. Okay, now next problem. Obtain Newton-Raphson formula for square root of n. N means natural number. Okay, so let us find the formula, generalized formula for the finding the square root of natural number. Here we consider x is equal to the square root of n, capital N. So here we first identify the function f of x. Okay, now the squaring both sides, then we get x square is equal to capital N. That is f of x is equal to x square minus capital N. Now the derivative, we require derivative also. F dash is 2x. See equation number 1. Now by Newton-Raphson formula, x suffix n plus 1 is equal to x suffix n minus f of x divided by f dash. Now put the value of f. The value of the f is x square minus capital N divided by its derivative is 2x. Okay, and write suffix n. Now simplify. 2 times xn is multiplied here. That is 2 times xn. That is x into x is x square minus. Now this minus sign is multiplied here. Otherwise, write this term, numerator term in a bracket, x suffix n bracket square minus capital N, and the whole denominator is 2 times xn. Okay. Now here, in previous problem we have seen, previous problem, first 2 problem, here 3. So here we get the 2 here because there is a cubic polynomial. This is the quadratic. So here 2 minus 1, that is the 1. That is x suffix n plus 1 is equal to 2 minus 2 times x square minus 1 times x square, that is 1. That is x square. Only remaining. Okay, minus sign is multiplied here, minus minus plus n divide by 2 times x suffix n. Okay. Now here we write 2 as a 1 by 2. Okay, in bracket x square divided by this x, that is 1x is cancelled, simply remaining x and suffix n, plus n divided by this numerator capital N divided by x suffix n is equal to x suffix n plus n. Okay, this is the general formula for finding the square root of natural number, which is required formula to obtain square root of natural number. Okay, now let us take the particular example. Instead of n, we take the any particular value. Let us solve for the n is equal to 2. Means the question is find the square root of the natural number. Find. Now the example on this problem, particular example, we take n is equal to 2. Okay, find the square root of 2. Okay, by Newton-Raphson formula. Solution. Now we have the formula for finding the square root of natural number. We have the formula x suffix n plus 1 is equal to 1 by 2 x suffix n plus capital N divided by x suffix n. Okay, and remember here n is running from 0, 1, 2 and so on. Here n is equal to 0, 1, 2 and so on. Here capital N is what? N is 2. That is x suffix capital N is equal to 2. Then formula is x suffix n plus 1 is equal to 1 by 2 x suffix n plus 2 upon x suffix n. Okay, say equation number 1. Now here the question is selecting the approximate value x naught. Okay, so first we identify the interval. For identify the interval, we must have the f of x. You see, the equation is x is root of 2. Now squaring both sides, that is x square minus x square is equal to 2. That is f of x is equal to x square minus 2. This is the function. This is the equation. Okay, see, we have discussed x square minus n. N is 2. Okay, now here we put x is equal to 0. X is equal to 0, then we get minus 1. Put x is equal to 1, again we get the minus 1, the minus sign. X equal to 0, we get minus 2. X is equal to 1, we get the minus 1. Put x is equal to 2. 2 square 4 minus 2, that is the 2. Here opposite side. That is root lies between 1 and 2. Root lies between 1 and 2. Okay, so here we select x naught as a 1 point something, otherwise 1, 2, Okay. So I'm selecting the nearest value. X naught is equal to 1.4. Now put n is equal to 0 here. Put n is equal to 0. We get first iteration x1 is equal to 1 by 2 x suffix naught plus 2 x suffix naught is equal to 1 by 2 1.4 x naught is 1.4 plus 2 upon 1.4. Okay, through calculate the value. Just wait. 1 divided by 2 x So here we get the first value is x1 is equal to 1.4142. We take the sixth number after the point 414285. Okay, this is the x1. Now put n is equal to 1 in equation number 1. That is x suffix 2 is equal to 1 by 2 x1 plus 2 upon x1 is equal to 1 by 2. The value of x1 is 1.414285. 5 plus 2 upon 1.414285. Okay, we get here the value of the x2 is 1.414285. We get x2 is equal to 1.414213. Okay, now next iteration, put n is equal to 2 in equation 1, and then here 2, then 2 plus 1 is 3. X suffix 3 is equal to 1 by 2 x suffix 2 plus 2 upon x suffix 2 is equal to 1 by 2 1.414213 plus 2 upon 1.414213. 1.414213. We get x3 is equal to 1.414213. So the value is repeated here. Okay, now we stop the iteration and we want the correct answer up to 3 places. 1.4141, 1, 2, 3. The fourth place is less than 5. Okay, that is the keep 4 as it is. So this is the approximate root of the 2, square root of the 2. Okay, thank you.